This is lesson 4.2, part 2. Okay, we're now going to use what we've just talked about with properties of exponents and the rules that we've talked about to simplify expressions. So we're going to use only positive exponents in our answers, so that means that your answer is not going to have anything negative, but we're going to use the rules that we just found. So number 19, if you look at what's inside the parentheses, there's nothing that could be simplified. I can't cancel x's and z's, for instance. What this is this is a power of a power rule, because I have things to a power given more power. So if you look back at your rule, the rule is multiply your exponents. Remember, x to the m to the n would be x to the m times n. So what I'm going to do is I'm going to take x to the fourth times 5, y to the third times 5, over z to the second times 5. So that's going to give me x to the 20th, y to the 15th, over z to the 10th. And that will be my simplified answer for number 19. Number 20 is also a power of a power. And so inside my parentheses, again, I cannot simplify anything inside. And that's one thing you always want to check. Can you simplify inside? It's kind of like if you're going to move from one bedroom to another bedroom in your house. If you start moving all of your stuff, you're not going to move things like all the trash and stuff, because you might as well clean that up first before you move, because you don't want to move the trash and then have to throw it away. So you want to clean up what's inside first and then move outside to what is waiting there. So there's nothing to do inside, so I'm going to have c to the 5th to the 10th. So that's going to be multiplied over b to the 7th to the 10th. So that's going to be c to the 50th over b to the 70th. And that's all there is to that. Okay, number 21, I also have power of a power. Everything inside the parentheses is going to get that third power. So negative 2 is going to get the third power. A to the second will get the third power. W to the third will get the third power. Y to the first will get the third power. So make sure you understand that every single item in there is going to get that power. So negative 2 to the third is negative 2 times negative 2 times negative 2, so that's negative 8. A to the second to the third is a to the sixth. Remember, we're multiplying our exponents, not adding them. W to the ninth, y to the third. And that is the simplified answer for number 21. Okay, number 22. If you look inside your parentheses, you've got a lot of things going on. I can't do anything with any of the variables. I could simplify the 3/12 to 1/4, but in the end, it's not going to matter anyway, because all of that is to the 0 power, and so that's going to be 1. Number 23, everything in here will get the second power. Everything in here will get the second power. So 1/2 is to the second power. W to the negative third is to the second power. W to the fourth is to the second power. So if we look at each piece one at a time, 1/2 times 1/2. Okay, this is a new one. W to the negative third to the second. Remember, the rule is to multiply. So I'm going to have W to the negative 6, because negative 3 times 2 is negative 6, times W to the 8th. Okay, now I'm not done, because number 1, I have a negative exponent, and the direction said I cannot have a negative exponent. Also, I can't leave it like this, because that should be simplified. It's like having x to the 6th times x to the 3rd. You can do something with that. So what we're going to do is we're going to decide what rule is this that it's showing right now. This is actually showing the first rule, the power rule, if you want to think about it that way. So remember, if I have the bases being the same, like I had in the very first examples, like if you have x to the third times x to the second, then you actually are just going to add up the exponents. So I could do that. I could add the exponents there. So I'm still going to have the 1/4, and then negative 6 plus 8 is 2. So that's one way that I could do that problem. There is another way to do that problem, so let me show that to you. Okay, another way to do that problem is, remember that w to the negative 6 would be 1 over w to the 6th. So what I would have then is I would have 1/4 times 1 over w to the 6th times w to the 8th. So that's, of course, over a 1. And so I'd have w to the 8th over 4w to the 6th. That's still not simplified, because if I have w's on top and w's on the bottom, I can cancel those common factors. What I'm going to have left over this is the quotient rule, I would do 8 minus 6, which is positive 2. So I'm going to have w to the second power. It's going to be on top because it was positive over 4. And so that's actually exactly the same thing as what I had before when I just added the exponents. I had 1/4 and then w to the positive 2. That's exactly the same thing. Okay, number 24. There's a lot going on in this problem. So what we're going to do before we worry about that, we're not going to worry about the second power right now. First, what we're going to worry about is what's going on inside. What can I clean up and simplify inside? So let's take it one piece at a time. The negative 18 does not have any power. It's just negative 18. X to the 0 power, that's 1. I don't need to write anything down for that. A to the negative third power, that's 1 over a to the third. So what I'm going to do is make my fraction bar, and I'm going to put a to the third down there. Okay, so I've addressed everything in the numerator. Now let's go to the denominator. 6, I'm going to put that down here. X to the negative second power. Okay, if it's x to the negative second, but it's on the bottom, it's going to come to the top, because really what we're talking about is we're talking about an inverse. Remember when we did matrices, if we had that, we would use the button on our calculator to find the inverse of that. And so that was the inverse, and it was the multiplicative identity. So remember that with matrices, if we had a matrix times its inverse, that was equal to 1. So if you have a number times its inverse, that's also equal to 1. So that's really what we're doing here, is we're just dealing with these inverses. And so that x to the negative second power, because it's on the bottom, is going to move up. A to the negative third, same thing. That's going to come up to the top. Now, once you've moved it, the negative is not there anymore. It does not change the sign out in front or anything like that. X to the negative third, that's going to go to the top as a positive 3. A to the third is going to stay below because it is a positive 3 and it's on the bottom, so it doesn't do anything. Now this is all still going to be raised to the second power, but I'm still not ready to raise it to that power yet. Let's simplify what's inside. So I start with a new fraction bar. The negative 18 divided by positive 6 is negative 3, and of course that would be negative 3 over 1, so that's going to go on top. If I put the negative 3 on the bottom, that would be 1 over negative 3. Now what I have here is I've got a couple of different rules I'm going to use. I'm going to use the power rule to have x to the second times x to the third. And then I'm going to have a to the third over here. And on the bottom, I'm going to have a to the third times a to the third is a to the sixth. Now, depending on your level of experience and your level of comfort here, you might be able to do a couple of those things all at once. But I wanted to make sure and show you exactly what I'm doing each time here. So I'm going to have the negative 3x to the fifth, but these right here, that's a quotient rule because I have the same base, a, so I could subtract my exponent. So when you have a to the third over a to the sixth, you're going to have a to the 3 minus 6, which is a to the negative third, which means that the a to the third power will be on the bottom. And if you think about, oops, I shouldn't square that in, we're not done. If you think about it, if you look at your a's, you have more a's on the bottom than you have on the top, so it makes sense that you would have those leftovers on the bottom. Okay, now I'm not done because I never did raise it to the second power. So I'm going to take my negative 3x over a to the third, and I'm going to raise that to the second power. That means negative 3 times negative 3, x to the second. So it's really x to the first to the second, but we don't need to write all of that. And then a to the third to the second, that means a to the third times a to the third, or a to the 3 times 2. That's my final answer for that question. So a lot of things to work out in that one, but the most important advice I can give you is to clean up what's inside your parentheses before you move outside. You could do it the other way. You could get this second power and give it to everything inside, but then you're going to just have bigger exponents to deal with. Okay, let's take a look at these fractional exponents. Okay, so if I'm looking at my fractional exponents, number 25, I've got x to the first power and x to the 1/2 power. The rule that applies is the power rule, the very first one that we saw, and that's where we add the exponents, so 1 plus 1/2. So that's 1 1/2, but we're going to write that as an improper fraction. And then this one, p to the negative first, that's 1 over p times, to the negative 1/2 power. So we can talk about how to do that, but that just means that 1 is going to have a negative 1/2 power and p is going to have a negative 1/2 power. And because they have negative exponents, this is going to go down there, this is going to go up here. That's a little bit complicated. We can actually simplify this significantly by looking at our rule. This is a power of a power rule. Power of a power. So if I look at that, the rule is multiply your exponents. So if I say p to the negative 1 times negative 1/2, that's just p to the positive 1/2. And so that is the simplified version of number 26. Okay, number 27, which rule applies? Well, since I have the same base on my variables, and this is x to the first power, I'm going to take this times this, which my power rule says that I do what with my exponents? I'm going to add them. So I'm going to have x to the first plus negative 1/2. And of course, I'm just going to take the 2 times the 4. So that gives me 8x to the 1 plus negative 1/2 is 1/2. So because of the rules, that helps me when I have fractional exponents. So we're going to talk about what fractional exponents mean and what they're used for shortly. So this will be how I'm going to write that. So when you write expressions, generally you're not going to end up with something to a negative power. Okay, this one, which rule applies? This is also going to be that first power rule. I'm going to take my 3 times my 2, but then for the v's, because I have the same base, I'm going to add my exponents. So 3/4 plus 1/4. So that's going to be 6. V to the 3/4 plus 1/4 is just 1. Okay, on this one, number 29, pay attention to what has the power. M has the negative 1/2 power. 3 has a first power. 2 has a first power. M has the 7/4 power. So looking at which rule applies, you've got something being divided, and we've got the same bases here. So this is the quotient rule that is going to help us here. And so what I can do is I'm going to have my 3 divided by 2, which I can't do anything about that. That doesn't simplify. So I'm going to have my 3/2. What I can do is I can say, since I have my base, I'm going to take my negative 1/2 and I'm going to subtract the bottom exponent. So like that. So that's 3/2. And then I'm going to have m to the, we've got to have some common denominators here. So if I have m to the negative 2/4 minus 7/4, that's negative 9/4. So we've already talked about how you can't have negative exponents in your answer. So what we're going to do is we're going to have the 3/2. Think about this as one giant fraction. M to the negative 9/4, that just means that if I put that on the bottom, then that would be correct. So that is one way to write that. We'll talk about what that means, like I said, in just a few minutes. Okay, number 30, the last one in this part of the video, we are going to look at, again, the quotient rule. So pause the video and see if you can get this one by yourself, and then come back and see. What you should have done, you're going to have a new fraction bar. The coefficient right there is 1. So 2 divided by 1 is just 2. So that's going to go on the top, because if you put it on the bottom, that would be 1/2. Now you look at the p's. They've got the same base. Actually, I'm going to erase part of my fraction bar first. So I'm going to have p to the exponent minus exponent. So 4/3 minus 2/3. So that's going to give me 2p to the 2/3 power, because 4/3 minus 2/3 is 2/3. And so that's what that's going to be with a positive exponent.